everyone, welcome to the course named Climate Change Extreme Events. Today is the lecture 8 of this course. In the previous lecture we have talked about different types of data sets which are used in particularly in extreme climatic analysis or in general climate change analysis. So, we have talked about already the data sets like the field observed data set or the at site data set, where we are collecting data at different locations, whether it could be land, terrestrial area, or maybe oceanic body, or the data set we are collecting in the atmospheric layers also. Then we have also talked about there are data set which are primarily collected through satellite sensors, satellite different types of satellites. So, these are the different we have talked about. There are active remote sensing and passive remote sensing, and then we have also talked about there are data set which are globally coverage data. This is global model, and then using the in situ data or the ground observation data or point location data, we can make some sort of reanalysis product, and that can also be can be used as a climatic data source, which basically used for various different purposes: understanding climate change, extreme analysis, precipitation pattern change, or let us say temperature extremes like that, or for example Arctic sea ice variations also. So, this is all about different types of data sets which are available, which can be used to interpret whether a particular location is experiencing any change in the climatic conditions since let us say 20-30 years or not, or is it a stable condition, or is it continuously increasing or decreasing like that. So, that is we have already discussed about. In this lecture 8, we will primarily focus on what is exactly data collection. So, gathering for example new climate data from different sources. These sources are either your point data or satellite observation, or let us say reanalysis product, something like that. Then this data set has some sort of errors or some sort of uncertainties there. We need to do some sort of pre-processing or processing to transforming the data into some other transformation into some other axis or values, so that we can have identify those data set where we have missing values. Then we can also use using the data pre-processing or processing step, we can visualize the data, and then we can interpret whether is there any problem with the data or not, or maybe we can go ahead with the data set whatever we have collected like that. Then there are several methods which are there available for error detection, which are identifying the inaccuracy within the data set, or there are several methods which are developed for error corrections. Implementation techniques detect errors like that, and then using all these data set we can think about ensuring your data integrity and how we can manage all these data set for better accurate prediction of climate pattern or climate change extremes in a certain region around different parts of the world like that. So, this is what is the total overall objective of this lecture 8. We will primarily focusing on the data collection and pre-processing part, and then we will go through each step one by one to understand what are these steps like that. So, in this lecture 8, we will first discuss about the challenges in the climate data collection. Then we will also talk about methods to handle missing data and errors. Then we will also talk about explore different techniques to identify or mitigate these temporal biases. And then we will also talk about what is the importance of this pre-processing to basically get a reliable data set for different types of climate data analysis like that. So, the first question which comes into the mind is why it matters when you have data you have collected, why it is important to improve the data set or correct the data set or remove the error. Because when you do not have accurate data in a certain location, it might be possible that whatever our interpretation is or whatever our modeling procedure is, it might have some sort of biases. It can lead to impact on different types of steps, which is basically climate data predictions step, or let us say if you are based on that data set you are making some sort of policies, therefore it also affect that policy making processes as well. So therefore when you have accurate measurement of data, that basically is a very useful to get an more clear insight about what is exactly likelihood condition of the climate in the future, or let us say what has happened in the historical condition, and how do we make some sort of different types of mitigation step to reduce the effect on climate change on different water bodies, or let us say different types of processes. So when we are dealing with the data quality, we are basically suggesting that reduces the uncertainty in the model output, or whatever the data set we have collected, we need to minimize the uncertainty as much as possible, so that we can have a very precise or accurate representation of the climate information at certain locations. So what are the common challenges when we are talking about data quality issues? There are missing values where we do not have values. Suppose we are measuring the rainfall at one particular location, there are few days when we do not have the information about rainfall. Or let us say if you are measuring the temperature record at a particular location, or let us say you have collected the data for reanalysis product or satellite data, it might possible that in certain grids we may have some sort of no values, or there are missing values, or there the a data set where we have get that particular data set has not recorded any value from that particular location. So that is called missing value problem. Then we have measurement error. Suppose you have installed an instrument at a certain location, and then instrument has been malfunctioned because of some reason. So that might create some sort of inaccurate data collection at certain location, and therefore that introduce some sort of errors in the data. So that is called measurement error when we are dealing with the data collection process. And there is sometimes it is also possible that there is an inconsistent temporal resolution. Suppose we are dealing with the daily temperature data or weekly data, that the temporal resolution does not match with the other variables or something like that. So what we can do in that situation, whether we need to bring down the temporal resolution to the all the variable level, or maybe we can do some sort of other things to maintain the temporal resolution across all the variables like that. So overall, when we are talking about importance of the data quality, we are suggesting the data collection, we are basically analyzing the data collection processes, whether it is based on satellite, ground observation, or some sort of modeling or reanalysis product. Then we are talking about data pre-processing, basically cleaning or filling the missing values and calibrating it, whether we have filled the correct value, or whether it is matching with the historical record or not, something like that. Then we will do some sort of analysis, either it could be statistical purely methods, or machine learning based, or visualization method, to basically look into it whether the data set we have collected, it has a certain a meaningful trend or meaningful seasonal pattern, or like that can be also used for multiple different purposes. Then when we have good quality data, it basically also gives us a more more confidence to use that data set for modeling for different climatic scenarios, or different types of historical assessment as well. And based on these historical and climatic scenarios, we can make some sort of decision making on policy, disaster, or preparedness mitigation steps like that. So there are several sources of errors in the climate data which can be possible, which we have just talked about. Instrumentation error. Suppose the sensor is malfunctions, or let's say there is a problem with the calibration. So when we install certain devices or certain measurement devices somewhere, it can have some sort of calibrations. So we need to calibrate that machine so that it can give us a more reliable data set. And if it is not done properly, then there is a problem with the error which we are introducing in the system, which is called sensor malfunction or calibration issues data. There is some sort of environmental factors also. For example, interference from local obstructions. It might possible that there is some weather condition or climatic conditions that might obstruct the collection of the data at a particular location. That also possible. For example, let's say during the snowy or heavy snowfall time, it might very difficult to measure some sort of weather parameters in different location. Or let's suppose if you have very high flood condition in a river channel, and lots of rivers or areas has been inundated, it's very difficult to correctly measure what is exactly the flow or what is exactly. So that is also some sort of obstacle there, and therefore we also consider these obstacle when we are planning to install some sort of devices in those areas where we have frequent flooding. Therefore we can correctly measure all these data set. Apart from these errors, there are human errors. Some, for example, if we are entering the data set manually, it might possible that we can also introduce some sort of errors in the data set. That is also possible, and that is can be a random error in the data analysis part. Then we have also some sort of data transmission issue. Suppose we are transmitting data from one device to another device, or one location to another location, or we are retrieving data from satellite to ground observation stations like that. It is not possible that there is some sort of loss of data might occur, and that might create some sort of errors in the data collection processes. So these are the some of the potential error sources where error can be generated, and that has significant impact on our data quality overall. So suppose we have the common causes of error in the data is missing data, for example due to, let's say, equipment failure or communication loss, or let's say some sort of random error created by these sort of processes. Therefore what we can do, we can there are several techniques which are available, which can be used to address these missing data gaps in the data set. For example, we can use interpolation technique, which can be either linear or spline method, or some more complex interpolation techniques, IDW, kringing, or all that can be also used to interpolate the data where we have missing values. That can be also be done. There are methods like statistical methods. There is mean mode imputation that can also be done to fill the gaps when we have the missing data set. Or let's say we have some sort of more robust or more advanced techniques, which is called machine learning based approaches, where we are using the k nearest neighbors or neural networks to basically identify what is the neighboring condition of your data set, and based on that information we basically fill our data record where we have missing data set. So this is one example where we have certain weather properties we are measuring, and we have missing data set. So like this, so there is possibility that if you can apply multiple different types of interpolation techniques. For example, if we have missing data, so we can use cubic spline, and that can give us this kind of curve like that. If we just use the linear data set, it can give us very straight line like that, and or maybe you can just left the data as it is, and we can use the data where we have the data sets available. So this is one example where it tells about when we select different types of interpolation techniques, it will give us a more different types of results, and based on the visual interpretation as well as the historical understanding of the process of that region, we select the interpolation or statistical method which basically best fit our data inherent properties like that. Suppose we have some sort of seasonal fluctuation of the data, and in one season we don't have data set. So in the previous few years or historical period of the season, we can infer that okay, the range might be somewhere something like that, and based on that understanding we can use some sort of interpolation or statistical methods to try to fill the gaps in the data set. Then there is another error detection techniques, which are, let's say there are few data points which are considered to be outlier. If you plot a box plot in using some sort of data, so there is a upper leg, and then therefore after that upper leg you have some dots, or let's say in the lower legs you have some dots. So these dots are generally representing the outliers which are slightly away from the whole distribution. And this is called outlier because this has a very distinct characteristics if you compare to the whole probability density of your data set. So, that is called outlier. There is a data validation and visual inspections. We can use all these different techniques to basically detect the error in the data, and then basically we can use some sort of recalibration of the data with some sort of statistical smoothing or removing the, let us say, outlier, or whatever the maximum value or very minimum value we have in the data set, we can smooth the values and we can remove the outlier, and then we can use that data set for multiple different purposes like that. So, this is the the flow chart which gives you an idea about, we have some sort of data input, we identified some sort of error, either it could be your outlier error or missing data error, or some sort of difference in your the behavior of the time series data set like that. We find out those errors in the data, then we apply some sort of data correction techniques, which can be your either interpolation based or statistical or data analysis based, or maybe we can also use some sort of more advanced machine learning or artificial intelligence based methods, where we can simply remove those data set based on the historical observation or historical records. Then there is a very important step for verification. Suppose we are applying some sort of statistical test or machine learning test in a certain data set, it is important step to basically verify whether your approach is giving the reliable result or not. Whatever we are filling in the data, whether that filled data is the correct representation of the data or not. So, what essentially we do that, we basically divide our data into, let us say, 80% or 20% or 70% or 30% zones. We use the 70 or 80% region for calibrating our model, or maybe using some sort of interpolation technique, and remaining 20 or 30% data set is used to validate whether the calibrated model or technique is giving us a reliable results or not. So, these 20-30% data set is not already shown to the method before, because it is only dealing with the rest of the 70-80% of the data set. So, that is how basically we can use it to verify our data, verify our model, whether it gives us a good result or not good result. Then we may have to replace this algorithm with some other algorithms like that. So, that is once the verification is done and we know that okay, our method is giving a good accuracy, or it is giving good results based on the previous historical data points or verification process like that. Then finally, we can use the data, that gap filled data or outlier detected data like that, and that is used for multiple different purposes for climate analysis like that. So, there are so these are how we basically manage the errors or uncertainties or missing data in the climate record, and how we can basically rectify them. There is a possibility of temporal biases in the data set, that is also possible. So, generally these temporal biases are considered to be temporal inconsistencies of the data set. So, for example, there is a seasonal gaps in data collection. Let us say we are measuring the flow or water discharge at one particular location, and there is a complete gap of one monsoon period of 1 year of that particular location. So, that is called seasonal gap we have created in the data set. We do not know exactly about what is the seasonal pattern of that year for that particular stations like that. Or let us say there is a possibility of, let us say, long term instrument drift or changes in the instrument, and that can also create some sort of temporal inconsistencies in the data set. So, what is the strategies to deal these kind of the inconsistencies or biases in the data? We may use the seasonal adjustment method. Generally, these methods are based on historical records, how the historical behavior has been observed, and based on those observations, we basically use that adjustment methods to basically fill that gap, whatever the seasonal, if the seasonal pattern is completely missing, then we will use that learning from the past and then we use that information to fill that gap. Or maybe we can use consistent monitoring schedules. Basically we have to prepare a layout, or we have to prepare some sort of consistent monitoring schedule for one particular operators, or let us say if somebody is going to collect the data, then we have to define, okay, at 8 AM you have to collect the water flow, at 3 PM you have to collect the water flow, something like that. So it is kind of consistent monitoring schedule, something like that. Or homogeneous technique, it's very important. For example, if we are using the same apparatus in 2011, 12, 13, 14, it has to be similar way, but might because of the year changes, it might possible that the technologies will also evolve, and therefore the measurement techniques or apparatus will also evolve over the time, might have lower uncertainty levels, something like that. So therefore homogeneous techniques can also be one of the step which we can reduce the biases in the temporal data set. So overall the workflow when we have corrected the data, or let us say we are comparing the seasonal fluctuation in the data or temporal biases in the data. First of all, we identify and correct the gaps, errors in the data based on the previous we have discussed. Then we will do some sort of normalization. Let us say we have multiple parameters in a certain location. We do generally normalization. Why? Because let us say we are measuring the temperature data, we are measuring the precipitation data, we are measuring the relative humidity data. All these data set has a different types of units, different types of measurement units like that. So it is not possible to compare all these data set and on a same scale. Therefore, first objective is to remove the units from the data set. It can be done by normalization process. Normalization is very simple. It is basically used by, we can use the mean of the data or standard deviation of the data, x minus mu by sigma. That is how we can basically normalize our data set, so that we can have data can vary between 0 to 1 or minus 1 to 1, something like that, a similar scale. And then we can basically use other data set, and then we can check what is their seasonal behavior, what is their long term trend, what is their short term pattern of the data set, like that. There is another techniques which basically also can be done by transformation of the data into different log power or other transformations models to stabilize the variance. Suppose we have a very high variance in the data set. Variance generally indicate that you have a data which has a very higher variability, and therefore to reduce that, stabilize the variance, we can use some sort of different mathematical model to basically transform the data into different axes, and that data can be used to compare our other types of variables like that. And then we basically aggregate all the data, and then basically we use that data information to correct or make it in a desired temporal resolution after the transformation step, using all the different variables like that. So this is how basically we correct the temporal biases or temporal or make a temporal desired resolutions for different types of data set. So the question is, all these analysis like gap filling, outlier detection, or let us say seasonal biases or temporal biases, how we can apply this technique, where we can use it. So the best the tools I have written here, we can use Python programming, which has several different libraries. For example, pandas, numpy, scipy, these are the different libraries which can deal with the data part, data analysis part. Or maybe we can use R programming language, where we have DPLYR or tidy year, that is one TIDYR, that is one library which can also be used for multiple types of error removal in the data set, or let us say data analysis part. Then there is some sort of specialized tools which we do not need to do coding on your own, but might use some sort of GUI or some sort of a minimal coding background, which can also be done using the climate data operators or there are NCLs, or basically these are the tools which are available which can be used for multiple error detection or error analyzing of the data set using these types of tools. So, generally when you are using the Python or R, you need to do some sort of coding on your own. So, when you do coding or when you basically use a data set in your coding environment, you can have a very good control on the data set. You can make multiple different libraries, use of the libraries, and you can use multiple different plots or basically error removal techniques like that. It can be also be done, but you have more options here. What is the benefits of these softwares? These softwares or these packages, library packages and all, is a very efficient handling for large data set. Let us suppose we are not only working on one station, let us say we are working with the 1000 different stations. So, manually we can check for one station, but if I say that okay, you have to manually check for all the 1000 station, it would be very difficult task. Therefore, we can use all these data set in these libraries. What we simply can do, we can use all the 1000 values or 1000 time series data in a for loop where I will vary from 1 to 1000, and then in each iteration the algorithm will pick one data at one time and then will correct the data according to your whatever you will be written here in that code like that. So, that is how basically we can efficiently handle the large data set, and we can use pre-built function for gap filling or error corrections, which means we do not need to write our own sort of error detection program or whole code. We can directly use the command which are available there, and that can simply do the gap filling thing or error detection thing or error correction thing or temporal biases thing like that in their environment itself. So, these are the some of very advanced tools, and one can use it to get hold of the data set using different climatic studies like that. So, these are the some of the case studies which I would like to discuss. For example, case 1 here, filling of gaps in rainfall using spline interpolation, where there is a gridded data and there are few places where the data is in coarser resolution or maybe missing data. So, we can use some sort of different interpolation techniques to fill that gaps and also reduce the resolution of the data. Kriging is one type of interpolation. IDW is also one type technique, and there is a spline method which is also a different techniques. In case study 2, basically they have done some sort of outlier detection and replacing them with the neighboring station data set. Suppose we have these are the data set where we have some sort of outliers there. We use the data in the neighboring stations or neighboring locations, and then we can basically remove the error which are or outliers or higher values which are present in the data set based on the local information or neighboring information like that. There is another case study which basically has done to compute the seasonal pattern or seasonal biases in the long term climate data set, and they have done some sort of analyze the sea surface temperature on different parts of the world, and then they have done some sort of seasonal biases to have a longer term climatic data set. Why it is important? Because when you have a longer term record of the data, so if you have also the seasonal pattern, it might have also in the few months it will be increasing and then another month it is decreasing like that. So, these trends, the fluctuations might change the perspective of long term pattern of a climate data set, and therefore, we basically remove this seasonal pattern from the long term climate data set record to get an idea about what is the overall longer behavior, long term behavior of a certain parameter in different locations. So, there we have discussed so many different types of data correction techniques, data interpolation techniques or biases removal technique like that. In all these different techniques, there is some sort of pitfalls or limitations. For example, there is a possibility that if you applying some sort of interpolation, we may encounter overfitting, which means we are overfitting the data set, and therefore the data might not naturally behaving, it might have some overfitted result. That is basically the error we are further creating because of these models like that. Or it is possible that we are ignoring the underlying data patterns. Sometimes we are just focusing on one particular type of the trend, one particular type of the seasonal pattern, and therefore we are ignoring the some other different patterns which are there in the data set. And in some methods, it is also possible that we are not assuming the correct biases or towards the biases like that, and that can also lead to some sort of inconsistency. So, better thing is we have to think about all these limitations which are associated with the model when we are applying certain different algorithm to correct the data set. So, the best practice is basically use the domain knowledge to guide pre-processing data set. We have to also cross validate with external data set, and we have to also document all your pre-processing steps so that we can identify at which step we have made some sort of errors or uncertainties. So, in this lecture we have primarily talked about what is exactly data pre-processing, why it is very critical for let us say quality analysis of the climate change analysis. We have also discussed about how to handle the gaps, errors and biases to ensure the data reliability. Then we have also discussed very briefly on the tools and techniques which are available to automate these processes. Let us say if you have a large data set of different climatic variables like that. So, this is we have covered in this lecture. So, based on this lecture we can do some sort of activity here. For example, we can identify a potential pre-processing challenges in the data set you have worked with. Either it could be your interpolation technique, or let us say gap filling technique or temporal biases technique. If you do not know exactly, if you have not worked on these techniques, maybe you can learn some of these technique, and then you can identify read about these techniques, and then you can identify what could be the potential error sources when we are removing the error using some sort of gap filling technique or interpolation technique or something like that. In the next lecture we will primarily talk about we will introduce the climate models and their specific characteristics. Thank you very much.